Hey everyone, welcome back to cfdsimplified. Today we are doing something different. We are stepping into the world of quantitative finance using OpenFOAM. Yes, OpenFOAM isn't only for the fluid flows, it has the solvers for the financial engineering. In today's video, we'll look up into the case of European call from the FinancialFOAM suite, which solves the Black-Scholes equation using the finite volume method. So what are you waiting for? Let's get started. Alright, so before we jump into the tutorial, I would like to discuss about what is Black-Scholes equation and what are the terms used there and what are the small topics are there. So we must know first about that, then only we can go on the tutorial part. So I have made one PowerPoint. We'll just go into that and then we will just move on to the tutorial part. Okay. So like as I have told you in the introduction part that this financial form solves the Black-Scholes equation. So basically this is the equation which you can see here above. This is the equation which the financial form solver solves. Okay, and what is this V, sigma, S? We'll talk about. I'll tell you later on in this PPT. Okay, so the Black-Scholes equation is a partial differential equation that describes the evolution of the price of a financial option over the time. Okay, basically when the time is increasing, like what is the price of the asset which you have invested. Okay, so it basically works as the prediction part. Okay, that whether over the time it will increase or decrease or what will be the part. Okay, so that is the thing. It was developed by Fisher Black, Myron Scholes and Robert Merton, and they won the Nobel Prize for this one. Okay, because it is like a breakthrough in the field of the modern financial theory. All right, so this is the thing. So let's now move on and discuss about what are these terms mean. Okay, these one, two, three, four, what are these terms means. Okay, so this is the this is the equation as you've already seen. Now what is V? So V is basically price of the option as a function of stock price S and time T. I will explain about what is option, what is stock price. Okay, time Okay, that don't worry. Just only try to listen about what are these, and then I'll explain each and every part of this. Okay, just like V is the price of the option as a function of stock price S and time T. Okay, option is basically here we are talking about any asset. Like option can be a stock also. Okay, if you're buying some stock of some company, or option is like something related to architecture, something related to infrastructure, like you own a flat or a bungalow or something like that. Okay, so it is like that. Okay, so V is the price, which is the function of that stock price, and price of the option, which is a function of the stock price and time T. Okay, del V by del T is the, yeah, as you can see that it is the partial derivative of the option price with respect to the time. You can say that rate of change of the value over time. Okay, that is the thing. V basically is, you can say, if in the in the easy way, it's the value of the thing which you are having. Okay, that is the part. Sigma is the volatility of the underlying asset. Okay, and now what is volatility? I have explained later on. We'll just go, just note down that. Okay, sigma is the volatility of the underlying asset. Okay, S is the current price of the underlying asset, like whatever you are having in your whatever you are owning. S is representing the current price of that part. Okay, del 2V by del S2 is the secondary partial derivative of the option price with respect to the stock price. Okay, or the current price. R is the risk free interest, like without involving any risk, what interest you will be getting. Okay, so that is the R representing del V by del S is the first partial derivative. Okay, with respect to the stock price. RV, this combine RV term, it represents the growth of the option value at the risk-free rate. Okay, so why it is how it is representing the growth, because V is the value, all right, of the option which you are of the option which you are having, and R is the risk free interest rate. So if you multiply both of them, it will give, it will only give you the growth. Okay, growth of the at growth of the option at the risk free rate, because R is the risk free interest. All right. Okay, so let's talk about, like, again, like, explain about what is this del v by del t means. Now, right now we have gone for the, for the explanation of the symbols in the equation. Now we will talk about, like, what is these terms mean in the equation. The first is del v by del t. Del v by del t representing the time decay. If we have to represent it by whole, we represent it by theta. So theta is equal to del v by del t. What does it mean? So it represents how the option value changes with respect to the time, that we have discussed in the previous slide also. Okay, options tend to lose the value as they approach maturity. What is maturity? Okay, maturity means like when their usage value, okay, if you talk about here, when their usage value is going to at the end, so it start losing their value. So for example, if you talk about the car, you buy a car and try to sell it in a year. Okay, so like, you can sell it by decreasing 10% cost, and you can sell it to someone else. Okay, so you will get a good amount of money. If you have used that car and you are selling after 10 years or 15 years after your usage, so after 10 years or 15 years, your car is going to decline, and it will be reaching at the extreme level of its operational value, despite of maintenance and everything. So at that point, if you are going to sell it, it will, you will get less amount. Okay, less resale price, if I'll talk about in that way. So del V by del T represent that, it represent that curve basically with respect to the time, that how the, what is the value, how is it changing with respect to the time. Okay, next one. Next one, this whole term, half sigma square s square del 2 v by del s2. This is the volatility term. Okay, so the term sigma square s square reflects the variance in the stock's return. Okay, like how much fluctuations is happening, you know in the this in your stock, in your, if we are talking about the shares. Okay, you will hear that word stock more in that part. But if in general, if I'll talk about, so like, you know what is the basically the this like, what is the trend, and what is the fluctuations in the in the price which you will get into return. Okay, so that sigma square s square is representing. Second derivative is representing the curve, the curve, the pattern, you can say, like what you are getting in a specific stock price. Okay, so together, if you club them, this term is representing the risk due to stock price fluctuations. Okay, you will be able to get assess the this risk, about how much risk is there if we'll go on this stock. Okay, yeah, and you can get it by seeing the fluctuations. Okay, don't worry, in the tutorial we'll plot the graph also. So from there you can just get the information about that. All right, next is RS del V by del S. What is this? It is the hedging term. Okay. So this term reflects how much the option price moves when the stock price moves. What does this mean? There is one stock price and there is one option price. Option price is basically, you can say that the return what you wanted to get. Okay, the value of your asset which is there. Okay. So stock price is basically the current market value, you can just say. Okay, like for example, let me explain it in a very simple way. Like you are owning a flat. Okay, and you wanted to know about, like, the flat value, it keeps on changing as the time. Okay, like the, what you can say, this the infrastructure value, if you can say, like, okay, right now it's something. If I take the example in the dollars, I don't know about how much it's in dollars in the price, but like, let's say example of $20,000. So right now it is $20,000, and after 10 years it becomes $50,000. Okay, according to the price of the market of the of that 2 BHK or 3 BHK flats which is going on at that point of time. So according to that point, the value of your asset is that one. Okay, so this del V by del S basically represents how the value of your price is changing with respect to the current, market trend which is going on. Okay, it's connected to hedging, adjusting portfolio exposures to changes in the stock price. Okay, so basically, like, you know, uh, what we can say, this if we talk about, like, stock price is there. Okay, it's like one thing is, one value is there. Okay, so like, how you can represent your asset to get a good value. Okay, so basically you can adjust your things, like, okay, like for example, if uh, uh, let us take the example of of a car. Okay, there is a trend in the market. So like, there is a trend that there's a time when sedans are in the use. Then there is a time that, okay, SUVs are more, more become more favorites of the people. So now you wanted to sell your sedan in the time of SUV, when the SUVs are favorite. What you can do? You can just, first you assess that, okay, right now SUVs are more selling. So what you can do is, like, you can change your thought, and you can represent the good things about your car, like about the engine performance, about the for example, about the infotainment system, about the comfort. Okay, so like, okay, people don't want the like sedans, but there are many people who like engine power, comfort more. So if car is able to give that, then okay, that's fine. They'll be able to buy it. So we can just show that one. So basically, with this term, you can just get to know about what changes you have to do to represent your product, your thing in the market. All right. Next term is RV. It is discounting term. So this represent the cost of carrying the option in terms of the opportunity cost. Okay. So since we are working in a risk neutral world, so this term helps adjust the option price to the present value using the risk-free rate. All right. So basically, here you have adjust about all your things. Now here you can, with the help of this RV, you can adjust your value of your car, basically, which you wanted to sell in an era of your sedan you wanted to sell in an era of SUVs. So like at what price you can just sell it. So with this term, you can just adjust that price. Okay, you can just adjust this price. Okay, so I know I'm also new in this one. I may have done I have researched the internet and everything. I may explain wrong thing. So yeah, if something is wrong here, I'm ready to accept the all the things. You can comment it down in the comment section, and I'll just try to repair it, or try to correct it. So repair is not the perfect word. Correct it in making another video on that. But okay, if I've explained something wrong in this term, I'm really sorry for that. I've researched the internet and then I've made, but yeah, things can go wrong. Okay, that's nothing. I'm not a perfect person. All right. Now let's move on to the key concepts for the Black-Scholes equation. Like I've told you that you have seen option is there, stock is there, volatility is there. So what does that mean? Okay, so let's discuss about that part. So what is an option? An option is a financial contract that gives the buyer the right, but not the obligation, to buy or sell an asset at a specific price on or before a specific date. Okay, so you must have understood by the definition only. But yeah, it is like the option is like a financial contract. Okay, like a contract, like a ownership. Okay, like it. So it gives basically the power in your hand. Like whenever I wanted to buy, I can buy. Whenever I wanted to sell, I can sell before a specific date. Like if some date is there, okay. And it doesn't contains any of the anything like the anything like terms and conditions. All right, anything like terms and conditions here. Okay, so there are two main types: call option and put option. Call option, it gives the right to buy an asset. Put option, it gives the right to sell the asset. All right, so this is the one thing. Okay, so think of it like booking a hotel room. So you pay a small fee, which is an option price. Okay, and you have the right to stay on a specific date. But if you change your mind, you are not forced to go. Okay, that's the no obligation part. Okay, that's the no obligation part. You are not forced to go. Okay, that is the part. All right. So let's move on to the next one. What is a stock? So stock represents ownership in a company. Okay. So like yeah, I mean you must be knowing about stock. What is there? When you buy a stock, you own a small portion of that company. The stock price is how much one share costs at a time. Stock prices fluctuate constantly based on supply and demand, news, earnings, etc. You must be knowing about what is a stock. I think not much explanation is needed here. Okay, now let's come to the stock price. Stock price is simply the current market value of the stock. In the Black-Scholes model, it's a variable that changes over time. The value of an option depends heavily on the stock price. Okay, value of an option depends heavily on a stock price. Okay, so like if we'll talk about this if you hold a call option to buy a stock of 100 rupees, okay, and the market price becomes 120 rupees, your option is profitable. All right, your option is profitable. Okay. So that is the thing. So it depends. Your option price depends on the stock price. Okay. Okay. Now what is volatility? So volatility measures like how much the stock price fluctuates over time, that I've explained previously when I was explaining the terms. Okay. High volatility means the stock price is very unpredictable. You cannot predict, like it is sometimes it is going up, increasing, sometimes it is decreasing. Very much change in the drastically change in the curve which you are getting. So yeah, that means it is highly volatile, and low volatile means the price is stable. Okay, like if it is started at $10 or $20, well, it remains on 20, 21. Okay, so like we can say that okay, the stock price is basically low volatile. Okay, black holes volatility is a key input. Higher volatility increases option value because there is more chance for the profit. But you have to be an opportunity, opportunity grabber basically. If I'll you can grab the opportunity as soon as you see that okay, it is increasing. All right, because if a stock is highly volatile, then there's a very high chance that in coming some after some hour it is going to decrease. So you have to, by experience and by having good hands, specifically if I talk about share market, so there you can just deal with it. Okay, so that is the part. So here if I'll give you the example, you can just uh, okay, so basically I have written the examples. Okay, so yeah, that's why I'm just reading that one. So here in the volatility you can think of the turbulence in the CFD. The more turbulent the market, the riskier and potential more rewarding the option. Okay, risk will be very high, but it will be giving you there is a very high chance of getting very good potential of getting a high reward. Okay, so that is the part. Now let's move on to the next one. What is time decay? So time decay refers to how the value of an option decreases over time. Okay, time decay, you can, by the decay only, decay means like it is something is decreasing, something is deteriorating. So it is like how the value of an option decreases over time as it gets closer to its expiry date. That what I have explained in the example which I've given of the car. Okay, so that is the part. That is the part. Okay. The closer we get to the expiration, the less time there is to make a profit. So options lose value with time, even if the stock price doesn't change. Okay, like the stock, you buy a stock at, for example, $50 or $60. Okay, and you are just having the options value, like you are having a price, but after the time your asset is going to reduce the value even though the stock price is same. Okay, that is what I wanted to say. Like for example, we can take the example of like imagine sand flowing out of an hourglass. Time decay is like that sand. Once it's gone, the option expires. Okay, that is the thing. Okay, so these were the things which I wanted to discuss, like the concepts, the topic, the Black-Scholes equation. This what I wanted to discuss in this part. Okay, so now we will move on to the tutorial part, to the OpenFOAM tutorial, like how it works, what is there in that part. So let's move on to that one. Before we continue, if you are working on a CFD, OpenFOAM or engineering simulation project and need personalized help, I now offer paid support and consulting. Whether it's setting up your case, debugging issues, or developing custom solvers, I'm here to help you move forward faster and more confidently. Just reach out via email in the description. Let's make your project a success. Okay, so let's move on to the tutorial of the financial foam. So we will go inside the CD form tutorials. So here you will find the directory of financial. If you go inside, you will find financial form. Inside that, inside that you will find European call. Okay, so I'll just copy this European call to my home directory, which is this. We'll go back, press ls, where it is, European call, yeah, here it is. Okay, so let's open that European European call. Okay, there is no all run file. So how to know about what are the steps? If to check about that, just go inside the system and check about what are the dict files are given. Okay, so here you can see that only block mesh dict is given. So we only have to run block mesh and then we can directly jump into the financial form solver. Okay, nothing in between, no snappy hex mesh, no surface extract, nothing, no decompose part. Just go for the block mesh and then we can run on the solver. If decompose part dict is there, then we have to run decompose part. If snappy hex mesh dict is there, then we have to run snappy hex mesh. Okay, that is the thing. So if no all run file is given in any case, then you just go inside the system and check about that one. Okay, so this is the one helpful trick to all of you guys. All right, so let's run block mesh. Okay, the mesh is ready. So should I first explain you about the block mesh, about the mesh, or about the domain, or alright, let me run the full solver, full case, then I'll explain you about everything. Okay, so for running, you have to type only financial form, solver of the financial form name is this, just press enter, it will solve, it has solved, press ls. We have the files here 0, 0.1, 0.2, 0.3, 0.4, 0.5, and for the graphs also it has written some files. If you go inside, you will see that gd 0.1, so files is there. So v.xy is basically the value what we discussed. Okay, and delta.xy is like the decrement. Okay, yeah, so that is the part, decrement or something. Okay, well, I'll discuss about that. Okay, so first let's go inside the para view and check about this what you've got. Okay, because solving something in OpenFOAM, you need to have a domain. Okay, so like we have a domain, like we solve any fluid problem. So like we have a rectangular domain in which any fluid is flowing and we are having some obstruction in between or something like that. So we see the changes, but here in the financial part, we have made a domain, but what that domain is representing. Okay, so that is the part, so that I'm going to explain, and because that is very important, because if you don't know what is the use of this. Okay, so we have to check that. Okay, so first I'll apply and I'll choose the wireframe. Okay, so here you can see that domain is here, rectangular domain is here. Okay, and it's a very good mesh, like you can see the quality of the mesh is really good. All right, so what is this representing? Basically, the you know this one is representing the this x1, if we'll call the along the x-axis, this is representing the stock price. Basically, what is the stock price right now? Okay, that is the one. And this vertical one, this y-axis, it is representing the v. What is v? V is the value of that option which you are containing right now. Okay, that is the one. So s, this in the x direction, if you can see this horizontal one, it is basically representing the stock price. Okay, and this y is representing the value. Okay, the this option. Okay, yeah. So how, what we are getting? Okay, so we have solved, so we will just choose this one and we will go in the surface and then we will select v. Okay, so if we'll go in the 0.5, I'll take the example of 0.5 because we are going to make the graph also of the 0.5. What it is representing, as you can see that as the stock price is increasing, as we are moving forward in the direction of the positive x-axis. So as we are increasing, you can see in the end the value is also increasing. You can see that it has increased up to 790. Okay, 790 the value has reached at the time of 0.5 seconds. Okay, So in the end of 0.5 seconds, with respect to the stock price, the value what we have got is this one, is 790. Okay, so in the end it has reached 790. It is starts increasing here, and after increasing we got the value of 790. Okay, so like, what I wanted to tell here is like this you use OpenFOAM for the financial part. Okay, because that is the thing. You, if you don't know about what you are, you know what is this we representing here and how it is representing, you will not be able to, uh, you will not be able to like perform any simulation or any operation. Okay, because if you don't know about thing like how is it working. Okay, so it is working like this. Okay, so like it is the, okay, so let us make a plot also. It will give you a good explanation about that. So I will open another terminal, and we will go inside European call. We will go inside the graphs. We will go inside 0.5. Okay, because we have seen the results on at 0.5 seconds only. So here you can see that one is v.xy and one is delta.xy. Okay, so let's plot the graph. Let's plot the graph. So I'll be using GNU plot. Okay, so first we have to go inside GNU plot. Okay, and then we have to set the terminal to PNG. Okay, then I'm just giving, you can simply, uh, type this one to get a plot, but it will not mark the, give the title to the axis. Basically give the title, and give the title to the axes also. It will only just plot it. We'll press enter, it has plot, and then we have to give how to save it. So to give this one, press enter. Okay, now we can exit, and here you can see that we are having the result. So to open, you can just use this command, press enter. Yeah, so here you have got, but here no marking, here no access marking, nothing is it, only showing v. Okay, so how to get all the markings? So for that you have to run the command in some in a, what you can say, in a stepwise manner. Okay, so yeah, so first again we will go into the GNU plot. We can plot it with the help of the Python also, but you have to write Python code, and then you have to, then it will read the values, and then it will plot. Python code may run or may not run. Okay, error can come. So here with the GNU plot you can directly plot. That is the part. So we'll just first we will set the terminal, set the terminal to PNG. Then we will just type for set. Okay, I'm just copying and pasting here. You can just type by your own. Okay, so paste. Okay, so these are the commands. What I've done, yeah. GNU plot set title. First is this command, so it has set the title, this one. Then next one is set X level stock price as, it has set Y table option price, set grid also, and then we are plotting. Okay, and then we press enter. Okay, it has plotted. Now to save it as an image file, we have to give these series of command. Okay, yes, these series of command one by one you have to give. Okay, so I'll just pasting it, and it has must have saved. So I'll just write exit, press ls. You can see one file is there. Now to view that you have to give this command, xdg hyphen open space option space the name of the file. Okay, press enter. Okay, so now you have got this one. Okay, so let me open the paraview also, and let me open the graph, and here you can see that as the stock price is increasing, as it has reached at 60, so here it is like, here it is the 60, so it has started increasing, and it has reached up to this value. Okay, it has reached up to this value. Why it is giving? Okay, we'll talk about delta. Let us plot delta also. This okay, let us plot delta also. So plotting 0.5, right? Okay, 0.5. Right. So I'll choose the same line of commands. Where first we will type chain plot, then we'll set the terminal png, then I will just okay, then I will just copy here and paste these commands, then I will exit. Okay, then to view I will just yes, here you are getting 60. Okay, so you can see that delta you are getting as the stock price is increasing, you can see around 120 it has started increasing, and then it has reached to the value of 60. So here you can see from the graph also the highest value is 60. Okay, I don't know why it has gone given the error. I have not seen beforehand. So if you'll try to solve it right now or try to figure it out, I think it will take much time. So I will figure it out and try to make another video like what is the value it was getting. Okay, but yeah, I mean from here you can just see that okay, it is in delta, it is matching up, the plot is matching the value basically. Okay, so this is the financial form. I was just going on some tutorials like on what next I can make. So I just, initially also, like when I started using OpenFOAM, whenever I open the tutorial of OpenFOAM, I always found it like what is this financial, I mean what is this telling? Okay, so I'll go inside tutorials. Okay, so I always have that one, that what is this financial telling, what is this financial? Okay, so that is the thing which I wanted to do. Another is like I always have an this interest here, like this one, this stress analysis, and here in the electromagnetics also. Let's see on from these both of them which one I can make the video, because it depends on the computational power also. Like if it doesn't demand computational power, or if my laptop meets the computational power which is required here, it's fine, I'll make the video. Like for example, for the 3D cover, I cannot make a video because I don't have that much of computational power with me right now. Okay, so that is one restriction with me. But yeah, I was like, okay, if my YouTube channel grows, I get some some financial help, okay, then I will definitely take the subscription of high power computing systems which is available, and then we can make any video, any simulation we wanted to run anywhere. Okay, all right, so yeah, this is the tutorial of FinancialFOAM. If you enjoyed this different flavor of OpenFOAM, hit the like button, leave your questions below, and don't forget to subscribe to CFD Simplified for more tutorials on physics, finance, and beyond.